Hello and welcome to this 7th lesson in the Year 7 Computer Systems series of work. As this is the last taught lesson in this unit, I'd like you to recap the following key questions before we start, and all of these have been covered in the lessons up to this point. Number 1, why are digital devices often preferable to analog ones? Number 2, what does the term binary mean? And number 3, how can I convert 01011100 into a normal number? Now you can use the internet for that, the person next to you if there is one, and any work you might have done last year. Pause the video at this point and give yourself 2 or 3 minutes to get those answers in your book. So as I said, this is lesson 7 in Unit 2 Computer Systems aimed at our Year 7 students. By the end of this lesson, we're going to remember what we've learned so far, particularly around the terms binary, digital, and processor. We're going to begin to understand the units of data storage commonly used in a modern computer, and we're going to be able to order those, so from smallest to largest. Through this unit, you've hopefully learned a lot about how computers work. We should hopefully know that computers are digital devices and they use a digital signal to help them store and transmit data more accurately. We spoke about the fact that an analog signal was much easier, much more straightforward, but it was very susceptible to interference. Digital computers shouldn't be. They store that data as ones and zeros, and we call that binary. And the binary ones and zeros are processed in the processor by millions of tiny switches in the computer CPU. Binary numbers put together, such as 0101, 0111, can be used to represent numbers and letters, as well as colours and sounds, and you'll look at colours and sounds as part of the GCSE course. Hopefully all of that makes sense, and if it doesn't, you might want to go back and have another look at one of the earlier videos in this series. So, one binary number, either a 1 or a 0, is called a bit. Okay, so 1, 1 or 1, 0, that is called a bit. 8 bits put together is called a byte. So 0101, 0101, that is 1 byte, and 1 byte is made up of 8 bits. And data is usually stored in 8 bits, so we would normally call it a byte. However, we do sometimes have 4 bits together, and those are called a nibble. So we would go bit, nibble, and byte if we were putting those in order. 1 bit, 4 bits, and then 8 bits, making a byte. With that in mind, what might the following terms mean? Kilobyte and megabyte. Pause the video and just think, what might those terms mean? Now you might be able to think about things like kilogram, if we were weighing out ingredients in cooking, to help you there. Pause the video just for 30 seconds and think, what might those terms mean? So I'd like you to pause the video at this point, and I'd like you to define the terms megabyte, nibble, byte, bit and kilobyte in your book, and I'd like you to put those in order. So in the question they're definitely in the wrong order, and I'd like you to order them from smallest to biggest. When you finish, I'd like you to see if you can create a mini acrostic style poem to help you remember the order. So I've given you a very basic example on the right hand side. You'd write the starting letter of each word down the left and come up with some kind of silly rhyme or silly poem to help you remember the order. Pause the video at this point, give yourself 10 minutes, and you can absolutely research online for those in more detail if you need to. Pause the video now. So there are a couple of other key units of storage. We know about megabyte, we know about bit and byte, but there are others that you might have heard of, and if not, there are others you might be able to spot in the image below. What might some of those mean? Pause the video at this point and see what other ones you might have heard of. So the other 3 key units of measurement that we need are gigabyte, terabyte and petabyte. I'd like you to pause the video now and have a go at researching those and then explaining what they mean. If you finish, you might explain how many bytes there are in each of them. Be careful, some of them are massive, so you might have quite a long answer to a couple of those. The number of bytes in a petabyte, for example, has got an awful lot of zeros. It might be easier just to write the number of zeros. If you have time, you might add those to your acrostics poems so that you can remember those as well. Pause the video at this point and have a go at that activity. So there are lots of what we call infographics online about data storage, and they give you lots of interesting statistics about how much data is being stored. So this one, for example, shows you the amount of data stored across the globe, and you can see that that is massive, measured in something called a zettabyte, which is way, way higher than any of the bits we've looked at. That's fairly old, but in 2013 there were 3.6 zettabytes of data created across the globe. This one shows the amount of data used in various social media platforms. So Google Mail, for example, stores 213 petabytes of information. Now, if we were to put that on A4 paper and put it into storage boxes, those storage boxes would be over 5 million miles long. That's way further than the moon and back. Facebook is 300 petabytes, which again is sort of 7 million storage boxes of information, a huge amount. This one is really interesting, and I suggest you pause at this point and make the video full screen so you can read it fully. There are 500 million tweets sent a day. Now, we know from last lesson that one letter is 1 byte, and we know that a tweet is, I think, 140 characters, although I might be wrong there. So from that, you might be able to work out how many bytes, for example, of tweets there are sent every single day. Like I say, there are some really interesting statistics on this slide, and this is going to link into our next activity. It might be worth having a pause at this point and seeing what interesting stats you can find on this page. So for the rest of today's lesson, you're going to create an infographic like the ones we've just seen. They need to include a range of statistics that you research online related to the storage of data and units of measurement. Some topics you might look at are the amounts of data held by big companies, maybe Facebook or Twitter, how much data is transferred over the internet each day, maybe using specific apps, or you might look at something more like the impact of things like junk mail on the environment. So every bit of data that is stored uses or needs a little bit of electricity. So if we think about 1 billion junk emails, how much electricity is that using each day? Now, you will definitely need to research those statistics online, and we're going to aim to create something like the previous slide. So I'd like you to pause the video at this point and create an infographic using research from the internet. I'd like you to research and fact check, if you can, a range of key statistics, and I'd like you to spend some time thinking about making your infographic really attractive and easy to read. Good infographics have the numbers in very big, clear letters, so it's really obvious what the statistics are showing. So you've got the rest of today's lesson, which should be kind of half an hour or so. I'd like you to look at the previous infographic and use that as inspiration, and you can use whatever software you'd like to create this. If I were creating it, I might use Photoshop, Photopea, PowerPoint, or Publisher, but you can use whatever you feel comfortable with. Pause the video at this point. So here is our self-assessment. Hopefully you've created something like this. It doesn't need to look as good as this one, but it does need to show off a range of key statistics. Pause at this point if you're unhappy with yours, and just spend a little bit of time to fine-tune if you need. So that is the final lesson in this series of work. Next week is the end of unit assessment. Hopefully you've met all of the objectives from today's lesson. You understand those key data storage terminologies, and you've created an infographic to show those off. As always, if you have any questions, please post those into the comments section below or directly onto Google Classroom for your teacher. Thank you very much for watching.